Hello everybody, welcome back to the night class. Today we're going to go over our chapter 7 review. This is from my Algebra 1 class. It's over factoring, and so let's get busy so the video is not too long. Alright, 1 and 2, it says what is the degree of each monomial. So the degree, just brief reminder that the degree is the highest exponent of each term. So there is only one term on both of these, so we're just going to figure out what is the highest exponents there. And when you have two variables, you have to add your exponents. So for this one, the highest degree is 10. And when it's just a constant, your degree will be 0. So, and it's 0 because it's really 4x to the 0 power is basically how you would read that. To know the degree. All right, number 3 says write the polynomial in standard form, then name the polynomial based on its degree and number of terms. So first things first, we're going to write it in standard form. So standard form, you put it in the highest degree down to the lowest degree. So the highest degree here is to the third power, so 4x to the third comes first. The next highest degree is 1 in that 7x term, so plus 7x. And then the lowest degree is just the constant, so -2. So that is in standard form. Now we have to name it based on this degree and the number of terms. So based on the degree, it is a cubic. Okay, it is a cubic because it's the highest degree. So it is a cubic, and based on the number of terms, there is 1, 2, 3 terms, so that makes it a trinomial. Remember, if the degree is 1, or excuse me, if the degree is 0, it will be a constant. If the degree is 1, it is linear. If the degree is 2, it is a quadratic. If the degree is 3, it's a cubic. For the number of terms, if there's only one term, it's a monomial. 2 terms, a binomial. 3 terms is a trinomial. All right, number 4, we're simplifying the sum, so we're just adding them up. So we add like terms. 4u to the third plus 4u to the third, that is 8u to the third. 2u squared, there aren't any more u squared, so you just put plus 2u squared. The next one would just be u. There's only one that's just u, that's -4u. And then last but not least, the constants are 7 plus 2, that is 9. So for number 5, it says simplify the difference. Same process basically. The way I do it, I like making it into an addition problem. So what I do is I change the sign to a positive, and I change all the numbers opposite of whatever they are on what's behind it, in the parentheses behind it. So we're going to have 6w squared minus 7w squared. That is -w squared. -8w minus 5w is -13w. And -4 plus 3 is -1. And that's all there is to it, just adding and subtracting like terms. 6 says simplify the product. That's just using the distributive property. So we're going to say 5a squared times 3a to the 4th. That is 15a to the 6th. You multiply the numbers and then add your exponents. 5a squared 5a squared times 3b is 15a squared b. And then 5a squared times 2 is 10a squared. And that is all you do. Always look to see if you have a common denominator or a like term, excuse me. But we don't, so we just leave it like that. 7 and 8, we are multiplying again, it says find the product, okay, the distributive property. So we're just going to distribute twice here. So 5h times 5h is 25h squared. 5h times negative 2 is negative 10h. 7 times 5h is positive 35h. And 7 times negative 2 is negative 14. Add your like terms if you have any. We do. Negative 10h and 35h are alike, so we're going to have 25h squared plus 25h minus 14 will be our final answer for that one. Okay. Number 8. Negative 2h times 5h is negative 10h squared. Negative 2h times negative 4 is positive 8h. 5 times 5h is positive 25h. 5 times negative 4 is negative 20. And again, you add your like terms, which again, we have h's that are alike. So our final answer will be negative 10h squared. 8h plus 25h is 33h minus 20. All right, 9 and 10, still multiplying. This time you're multiplying a binomial times a trinomial. So it's the same process, it's just a little longer. 4k times 2k squared would be 8k to the third. 4k times negative 5k is negative 20k squared. 4k times negative 4 is negative 16k. Now we go to the 5. 5 times 2k squared is 10k squared. 5 times negative 5k is negative 25k. 5 times negative 4 would be negative 20. And then again, we add our like terms. So 8k to the third, there aren't any other k to the third, so it comes first. We have negative 20k and positive 10k, negative 20k squared plus 10k squared would be negative 10k squared. Negative 16k minus 25k is negative 41k. And we only have a negative 20. So you just put that on the end there. So that is your final answer. Okay. 10, you're doing a trinomial times a binomial. So, let me get these out of the way. We're going to say 2k squared times, 2n squared times 3n will be 6n cubed. 2n squared times negative 5 is negative 10n squared. Then we go to the 5n. 5n times 3n is positive 15n squared. 5n times negative 5 is negative 25n. And then last but not least, the 2. 2 times 3n is 6n. 2 times negative 5 is negative 10. So add your like terms. 6n cubed, negative 10n plus 15, negative 10n squared plus 15n squared is positive 5n squared. Negative 25n plus 6n is negative 19n. And minus 10 is our last. Okay. Number 11. We're still multiplying, so if you want to write this out twice, you can. There is a shortcut. The shortcut when you are adding something like this, you're just going to square both terms in your binomial. So that'll be 64m squared, and 1 times 1 is 1, so plus 1 will be on the end, and in the middle you multiply the two terms. So 8m times 1 is 8m, and then you double it. So you multiply that times 2, you get 16m. That's what goes in the middle. So 64 squared plus 16m plus 1. Again, if you want to write it out the long way, you always can. You would write out 8m plus 1 times 8m plus 1, and then do it like we did up here on number 7 and number 8. Okay, no big deal. 12 and 13. These again are also special cases. We can do a shortcut here. We don't have to do all 4 of them because these are going to cancel. The middle ones will cancel because these are exactly the same. It's just you have a minus sign here and a positive sign here. So as long as everything's the same, they're just opposite signs. You just have to do the first and the last terms. So 3p times 3p is 9p squared. Negative 6 times 6 is negative 36. And that's all there is to these. But again, you can only do this shortcut when they are exactly the same, just one's adding, one's subtracting. So 6m squared times 6m squared is 36m to the 4th. And negative 6 times 6 again is negative 36. So that is all there is to those. 14. 14 is our word problem. So I'm going to shrink this a little bit. I'm going to come over here and use my notebook paper. First it says, a machinist creates a washer by drilling a hole through the center of a circular piece of metal. If the piece of metal has a radius of x plus 9 and the hole has a radius of x plus 3, what is the area of the washer? So I am going to draw some shapes over here. I'm going to draw me a circle. This will be the piece. Whoa, let me try that again. I'll just draw it. How about that? I won't try to cheat. All right, so I don't like that one either. Let me try it one more time. I'm going to draw it a little bigger. All right. All right. Sorry if my circle's not up to your specifications. So that's the piece of metal. Here is the hole in the washer. Okay. And basically they want to know what is the area of the washer. So what's the area here? Okay. What's the area of the donut looking type thing? Okay. So let me change. So the radius, it said the radius of the piece of metal, so that's all the way to there. It said was x plus 9. Okay. And it said the area or the radius of the hole, it said was x plus 3. Okay. So to find the area of the washer, we are going to find the area of the piece of metal and the area of the hole, and to find the area of the washer, we're going to say the area of the metal minus the area of the hole. Okay, so first we have to find the area of the metal. So area of a circle is just pi times radius squared. So that's going to be pi times the radius of the metal is x plus 9 squared. So that will equal to pi times, again I'm going to do my shortcut, so that would be x squared plus 9 times x is 9x times 2 would be 18x plus 9 times 9 is 81. And if I distributed my pi, I'll get pi times x squared plus 18 times pi times x plus 81 pi. So that is my area of the machine, or the metal, excuse me. So the area of the hole, again, it's going to still be pi r squared, but my radius is different. So this time it's x plus 3 squared. So that will be pi. And when you square x plus 3, you get x squared. 3 times x is 3x, times 2 is 6x, plus 3 times 3 is 9. And we distribute that out again. So that will be pi x squared plus 6 pi x plus 9 pi. And now you simply subtract those two expressions. So pi x squared plus 18 pi x plus 81 pi minus, and I'm going to put this in parentheses because you're subtracting the entire thing, pi x squared plus 6 pi x plus 9 pi. Okay? And so basically, again, I'm going to do this like I did a minute ago. I'm going to change this to a plus. So I'll make that a plus, which makes that minus, and this a minus, and that a minus. So again, that's just my way of subtracting. So for my final answer, the area of the washer is going to be, let's see here, so we have pi x squared minus pi x squared, those cancel. Okay. And 16 or 18 pi x minus 6 pi x is 12 pi x. And 81 pi minus 9 pi, let's see here, that would be what, 72 pi. That is the area of the washer. 12 pi x plus 72 pi. 12 pi x plus 72 pi. So that's kind of a long one, but it is what it is. Okay. 15. I got room to work 15 right here. So 15, it is almost exactly a carbon copy of the problem we just did. The only difference is it's a square this time. So these sides are x, it says. It says a square painting is surrounded by a frame. The edges, the outside edges of the frame are x inches. And there is a 4-inch border between the painting and the frame. So understand, that's not saying this whole thing is 4 inches right here. Okay, that's not what it's saying. It's saying the distance from here to here is 4 inches. And the distance from here to here is 4 inches. And same thing from there to there and from there to there. So this border that goes around it is 4 inches. So it wants to know what is the total area of the border. So again, we're finding the area of the white part here, the area of the border. So very similar to the last one, we're going to say find the area of the outside circle, or not circle, but square. So the area of a square is the side squared. So in this case, our side for the outside is x squared. So that's our area of our outside. The area of the inside one, again, still side squared, but what is the inside? Well, this distance right here is going to be the whole distance here, x, but it's minus 4 on each side. So that would be minus 8. And that means this side is also x minus 8. Okay, so this side would be x minus 8 squared, which is, again, if we do our shortcut here, we'll have x squared, multiply them together, negative 8x times 2 is negative 16x, and then negative 8 squared is positive 64. So this is the area of the outside, this is the area of the inside. To get the area of the border, we're going to subtract, or say the area of the outside minus the area of the inside. So that will be area of the border, area of the outside was just x squared, minus, again, I'm going to put all this in parentheses, x squared minus 16x plus 64. I'm going to change that to addition, which makes that minus, plus, and minus. So the area of the border, the x squareds cancel. X squared minus x squared is 0. So we'd have 16x minus 64 left. So very, very similar to number 14. The only difference is instead of being a circle, it is a square this time. Alright, that takes care of our multiplying pretty much. So now we are going to go to the factoring part. So 16 and 17, they say find the GCF. That stands for greatest common factor. And so all you're doing is figuring out what's the biggest number that will go into all three terms. So this term, and this term. And also what's the largest variable that will go into all three. So 46, 40, and 34. The biggest number that will go into all three of those evenly is 2. And x to the third, x squared, and x to the fourth. As long as they all have the variable, you just pick the one that's the smallest. So it's 2x squared would be your greatest common factor. Okay? So I'll just put equals greatest common factor. Okay? So here we have a binomial. 46 and 26. Again, I think the biggest number that'll go into both of those is 2. And they both have an x, and the smallest one is x squared. So 2x squared is the greatest common factor on that one as well. Just happened to be the same exact thing. That doesn't always happen. 18, 19, 20, and 21. These are your trinomials that you're going to be factored. So we're going to make our two parentheses and figure out what are the factors. So I'm just going to do them all real quick here. Save a little time later on. So we have D. So we're going to have D. D and D. And we're looking for two numbers that multiply to be 7 and add up to 8. Well, that's pretty easy. That's 7 and 1. Alright. So for number 19, again, we'll have D and D. We're looking for a number that multiplies to be 45 and adds up to negative 14. Important there. So if they're multiplying to be a positive number, you know these numbers have to be the same sign. So they both have to be negative because they have to add up to negative 14. So what multiplies to be 45 and adds up to negative 14? That would be negative 9 and negative 5. Negative 9 times negative 5 is 45. Negative 9 plus negative 5 is negative 14. D and D again. Again, we're looking for two numbers that multiply to be negative 36. Add up to 5. That would be positive 9 and negative 4. And last but not least, two numbers that multiply to be 27 and add up to be negative 12. So let's see here. Numbers that multiply to be 27. That would be negative 3 and negative 9. And negative 3 plus negative 9 is negative 12. Negative 3 times negative 9 is 27. Negative 3 plus negative 9 is negative 12. So that's all there is to those. 22 is a little more complicated simply because they added a y in here. But basically you do it the same way you did 18, 19, 20, and 21. You just add a y on the end of your number here. So we're going to do the same thing. We'll have an x. We're going to have an x. And so we're looking for two numbers that multiply to be negative 8 and add up to be negative 7. That would be negative 8 and positive 1. And since we have y's on the end, all you have to do is put a y on the end in your factors. So again, like I said, basically you're doing exactly the same thing you were doing on 18, 19, 20, and 21. All right, 23, excuse me. what is the expression in factored form? So we're just, again, factoring. These, however, you need to always check for a greatest common factor first. So none of these had a greatest common factor on 18, 19, 20, 21, 22. 23, and 24, they do have a common factor. So the common factor between on 23 is 5. So we're going to bring 5 out. We're going to divide everything by 5. And that's going to go in the parentheses. So that'll be x squared plus 7x plus 10. And then you ask yourself, can you factor what's in the parentheses? And the answer is yes, because we can find two numbers that multiply to be 10 and add up to be 7. So that's going to be 5. And two numbers that multiply to be 10 and add up to 7 are 5 and 2. 5 times 2 is 10. 5 plus 2 is 7. And the little 5 that you brought out front, it just comes along for the ride. So we're going to do the same thing on 24. So we got negative 2, 2, and 40. Well, we can factor out a negative 2 there. If your first number here is negative, just factor out the negative with it. Okay, so we're going to divide everything by negative 2. And so we will have x squared minus x minus 20. Now, like I said, sometimes that's as far as you can go, but in this case, just like in the last case, we can factor what's in the parentheses. So that's going to be negative 2 and 2 parentheses. Let's see here, we're looking for numbers that multiply to be negative 20 and add up to be negative 1. So that would be x minus 5 and x plus 4. And those are your factors. All right. 25. Let's see here. Let me erase this a little bit so I have a little more room. Okay, so I'll start 25 up here. So 25 is one where you have to, there's a couple ways you can do it. I'll do one of each way. Doesn't matter how you do it. It's whichever way works best for you. So the first way I'm going to show you is by grouping. So to do the grouping, you're going to take the a and the c, and where am I getting that? Ax squared plus bx plus c. So it's always the a times the c. Okay, so the a times the c here would be negative 60. And we're looking for two numbers that multiply to be negative 60 and add up to be negative 28. So, so I'm going to rewrite my problem here. The 5x squared stays like it is, but I'm going to transform my negative 28x into the factors. So let's see here. The factors that would multiply to be negative 60 and add up to negative 28, I could do negative 30x positive 2x. And then you just finish writing the problem. Minus 12. Now, again, negative 30x plus 2x is negative 28x if you were to add them up. So I'm kind of making it bigger. Okay? So then we take our groups. Okay, oops, didn't mean to erase that minus sign. We take our groups. This is a group, and this is a group. And you factor those groups. So the greatest common factor in this first group is 5x. So if we take that out and divide by 5x everything, that will leave us with x minus 6. And 2x and negative 12, the common factor is 2. And if we divide those by 2, we'll also end up with x minus 6 in my parentheses. Now you can see that these two things have x minus 6 in common. So I just bring that x minus 6 out front, and I divide both by x minus 6. Those all cancel. I'm left with 5x, and here they cancel, and I'm left with plus 2. And there is your answer for 25. 26. We're going to do this one by a method that I call borrowing. And again, it does not matter which way you like doing it. They both work, okay? So when I borrow, what I'm going to do is my problem over here is I'm going to take this 5 and I'm actually going to move it over here with the 18. So I'm still multiplying them. I'm still doing A times C. I'm just moving the 5 over, okay? Now when I do that, I get to rewrite it x squared plus 21x plus 90. So 5 times 18 is 90. That's where the 90 is coming from. So I'm looking for two numbers that multiply to be 90 and add up to 21. And I'm factoring just like I have been in the problems before this. So two numbers that multiply to be 90 and add up to 21. That would be 5 and 16. 5 times 16 is 90. 5 plus 16 is 21. Okay? Let me just make sure of that real quick. I'm doubting myself here. I'm getting my calculator out. 5 times 16. 5 times 16 is 80. So let me see here. That can't be right. So 90 divided by 4. Nope. 90 divided by 10 is 9. That would add up to be 19. So let's see here. 90 divided by 3 is 30. Nope. So these are wrong. Apologize. I did that all wrong. So let's see here. 90 divided by 9 would be 10. Nope. 90 divided by 8. I can't figure it out. 90 divided by 6. There it is. 6 and 15. What did I say? 4 and 15? I was silly. 6 and 15. Sorry about that. Is that right? 6 times. Yes. Okay. Now we're cooking with gas. We're good. 6 times 15 is 90. So we are going to, now remember, this is called borrowing. So remember, when you borrow something, you have to put it back. So we borrowed this 5 by multiplying it. So we're going to put it back by dividing by 5. And all you do is you simplify your fractions. 6 over 5 is simplified. So you take your, if you have a denominator still, you move it to the front of your binomial and leave the numerator alone. So 5x plus 6 here. 15 divided by 5 is 3. So we say x plus 3. So, little trouble on that one because I don't know, I guess I was adding wrong or something earlier, or maybe I had it right the whole time and my brain's just not working. Anyway, that's the right answer. All right, 27. Just understand 27 and 28 are just like 25 and 26. They're just in word problems and they're multiple choice. So it says, what are the possible dimensions of the pool? And it even tells you how to work it. Use factoring. So we are going to factor. I'm going to come over here. We're going to factor 6y squared plus 14y minus 40. So come over here. 6y squared plus 14y minus 40. As always, we're going to take out the common factor first, the greatest common factor first, which what number will go into all those? 2. 2 will go into all of those. So when you divide everything by 2, you get 3y squared plus 7y minus 20. And now we have to borrow inside here. So 3 and negative 20 make negative 60. So let's figure out, let's see here. Oh goodness. I hope we don't, you know what? I said borrow, so let's borrow. I'm going to borrow here. Multiply that. So we'll have 2 times y squared plus 7y minus 60. So again, I'm taking this, I'm doing it the borrow way. I'm doing it like this one. Okay? So I'm borrowing that 3. What numbers multiply to be negative 60 and add up to 7? So let's think here. So I'm going to actually grab my calculator so you can actually see me thinking. Okay, so I'm trying to get, let me make sure I know what I'm trying to get here. I'm trying to get negative 60 and add up to 7. So I'm going to take negative 60. I'm going to divide that by, well, I know it's divisible by 10. So that would be 6. So 10 minus 6 is not equal to 7. So try again. Negative 60 divided by 15 will go into it. Negative 4. 15 minus 4 is not 7. So, but if you notice, 10 minus 6 was 4. 15 minus 4 is 11. So it's got to be in between those two numbers. So negative 60 divided by, let's try 12. I believe we have our winner. 12 minus 5 does equal 7. So we got 12 and negative 5. So positive 12, negative 5. We borrowed the 3, so we are going to put it back. Divide by 3 and divide by 3. So my final answer here will be 2 times y plus 4 times, again, if it doesn't reduce, you just move that to the front, 3y minus 5. So let me come over here. These are my 2 times y plus 4 times 3y minus 5. And if you notice, my answers, I don't have this for any of my answers. So what they did, here's my answer. It is C. And here's why it's C. So obviously, there's 3y minus 5, and there's 3y minus 5. So if you notice, none of the other answers have 3y minus 5. But how did they get the 2y plus 8? So here's what happened. You could multiply this 2 back in here, and you get 2y plus 8. So that's why that's there. Okay? So 28, very, very similar problem. It's giving us what is the dimensions. So I'm going to write it here, 8x squared plus 2x minus 45. I got a little room to work. So there is no common denominator on this one. So what I'm going to do is I'm going to borrow, once again, x squared plus 2x minus, let's see what 8 times negative 45 is. Negative 360. So minus 360. And I'm playing the game here. X times x. We need a number that, two numbers that multiply to be negative 60 and add up to be 2. Negative 360, excuse me. And add up to be 2. So negative 360 divided by, oh, let's say 30. 30 minus 12 is not 2. So a little bigger. Negative 360 divided by 40. Let's see here. 40 minus 9 is not 2. So I guess I'm going the wrong way. Let's try the other way. Negative 360 divided by 20. Ah, there it is. Because 20 plus negative 18 is 2. So 20 and negative 18. So plus 20, negative 18. I'm going to put back what I borrowed. So I borrowed an 8. Divide by 8. Neither of these divide, so I'm going to reduce the fractions first. So x plus 20 over 8 will reduce to 5 over 2. And 18 and 8 will reduce to 9 over 4. And you take your denominators and put them in the front. So my final answer would be 2x plus 5 times 4x minus 9. So 2x plus 5, 4x minus 9 is also the letter C here for 28. All right, the last 5, these are your special factors. So they're special cases. So be careful on how you write your answer. So like here, we're looking for two numbers that multiply to be 9 and add up to 6. That will be d plus 3 times d plus 3. But they don't want you to leave your answer like that. They want you to simplify it a little more. That's d plus 3 squared. That's all they're wanting you to do there. So here, two numbers that multiply to be positive 121 and add up to negative 22. That's d minus 11 and d minus 11, which is d minus 11 squared. All right, the last 3, 31, 32, and 33, this is the difference of squares. Okay, when you have 4's x squared is a perfect square, negative 81y squared is a perfect square. So when it's like this and you are subtracting, you have to be subtracting, and these have to be perfect squares. If they're not both things, you can't do what we're about to do. Okay, so basically to work this, I'm going to put my two parentheses. I'm going to take the square root of this, that is square root of 4x squared, it would be 2x, goes there and there, and the square root of 81y squared is positive 9y and negative 9y, and that's all you have to do there. Okay, so this one again, perfect squares, so take the square root, that would be k and k. 16h squared would be positive 4h and negative 4h. You do the positive and negative of the one that's minus, of the one that you're subtracting. Okay, and our final one, wait a minute, 32 and 18 are not perfect squares. So we need to figure out, is there a greatest common factor first? And there is. 2 will go into both of those. So take out your 2, and that will leave you with, if you divide both of them by 2, you'll get 16x squared minus 9. And now we have two perfect squares. So now we can do it the shortcut. So that's going to be the square root of 16x squared is 4x and 4x, and the square root of 9 is plus 3 and minus 3. And that is our final answer and our final question. I hope this helps. Study hard. We'll see you next time, and as always, stay above the line.